case, if you feel like yesterday one student, the whole questionnaire is wrong, okay, right? The whole dependent variable is wrong, okay? She went and took it from the, I don't know from where, God knows, factors, okay? So it's totally wrong. But it's okay if you have done it in your assignment 2, you want to change the question, the items, you can change, understand? So if you want to add on, you want to remove something, please do. Because if you don't do that, the whole assignment will be wrong. Understand or not? But you cannot change the variable. You cannot change the dependent variable and the independent variable. Are you all clear about this?
Yes.
All of you all good, huh? Okay. And then after that, alright, so if you want to add, fine. So if you feel that your questionnaire and your reliability is really bad, okay, look through the questionnaire again. See your scale. These are the things I'm seeing, alright. I didn't have problem with this in S2, you know, a lot of problems in here. So I don't know whether there's something wrong with me or y'all. Okay, alright, because I'm teaching the same way only.
They're a bunch of nerds.
Okay, so the Likert scale is supposed to be strongly disagree, number 1. Strongly agree will be number 5. Understand? So if you have done wrongly, okay, don't try to be a hero and say, never mind, those who put 1, I'll change back to 4. Those who put 2 cannot. You know why? How many people, how would you know who read and who didn't read? Yes.
I see here it says 0.6 above is still acceptable with citation.
For reliability, not pilot.
Of the main 70 sample one.
Yes. Okay? Alright, so therefore you have to redo again. I know it's difficult to get 30 sample, so maybe you can try, okay, 15, remove the first 15, try to collect the second 15, then you put in lah. You know, that's the, in another way you're cheating lah. But what to do? Okay, then you run the test and see. So if you're still not reliable, put back the same 15, remove the down 15, okay, and then put your new one again. So you try. You still cannot, then you have to collect the whole 30 lah. Okay, right? So this is another mistake that I found that the students, okay, in this classroom went through. Not one, a few of them. Okay, so for pilot study, the Cronbach alpha, I'm just doing a summary, alright, a Cronbach alpha should be more than 0.7. So if you don't get more than 0.7, you cannot go ahead with the test. Yes, you wanted to ask me something? Oh, anything? No, huh? Okay. I thought you were. Okay. Alright, so you cannot go ahead with if it's less than 0.7. Understand? Okay. Pilot test, all clear? Any question? Raise your hand. Have I scolded you? No, right? Before, so you can always ask me. Any question? No, so done. Now with the new data, meaning you have collected after 0.7, you are collecting more data. Oh yeah. So if for the first 31, alright, so say your reliability is low and then you need to remove something, you can remove it, but under your pilot data, the interpretation, you say that this particular question was removed to get a good reliability score. That's it. So for the new respondent that you're going to give, are you going to include that question?
No.
No. You're not going to include that question because that question is a problematic question, right? So you're not going to include. So you remove that question and you send in a new set. Now when you send in the new set, you do a reliability test again. Why you need to do? But this time you don't call it pilot, you call it reliability. But same step, okay? You do the reliability test again, and if you get 0.6 above, it's still acceptable. This is for the big sample, understand? So 0.7 you don't get, it's okay. If you get 0.61, 65, 62, whatever, as long above 0.6, it is still acceptable. Just need to put a citation. There's a lot, alright? There's a lot. Okay, you just need to put the acceptable citation. All these are in a HLMS, alright? Okay, so clear with this? Can. So how do you do the reliability test? We simply do what? Okay. Now you guys teach me. How do you do reliability test?
Analyze.
Analyze.
Scale.
Scale. Reliability.
Analysis.
Analysis. Okay. So do you take the gender and age?
Tidak.
Yeah.
No.
No.
I said tidak.
Oh, tidak. Okay. I heard as yeah.
Take the
Okay.
pews.
Alright, okay, so you need to take this. Okay, the first one, okay, you just put in. Alright, okay, I'm just doing a summary, okay, because I know it's so many confusion. So I don't want all this confusion anymore. Alright, because I will not be seeing, I'll be seeing on Thursday. It's a bit too late if you make a mistake. So go to statistics. And then you click. Yesterday somebody didn't know. Must click item, scale, and scale if item deleted. I didn't tell, you laugh. Okay? Alright, so you must click all these three. Then you press continue. So what is the name? Okay, then perceive is of use. Okay? Alright, then you press OK. Understand? This is how you do the reliability test. So you need to do reliability test for IV only, right?
No.
No, good. You have to do for IV and DV. So are y'all good with reliability test now?
Yes.
Can. Yes, sir. Anyone? No. Okay, so once you've done your reliability test, you know that you have gotten everything above 0.6 also is still acceptable with the citation. So you have already done the reliability test. So you need to do the descriptive test. Okay? So how do you do the descriptive test? Okay, go back. How do you do? Analyze. Okay, descriptive statistics. Okay, all of y'all. Next one, what do you do? Frequency, not explore. Explore is for the normality or linearity, somewhere there. Not explore. Analyze, descriptive statistics. Okay, and then after that, frequency. This is for demographic, right? Okay, can? All of y'all? Can? Okay, so you click the board. Okay, you get this table appear here, right? So for this, what kind of variables do you use?
Demographics.
Demographics. So how many demographic you have? Whatever demographic you have, you put it over here. Understand?
Yes.
Can? So you put gender, example. You put in the variable over here. So then after that, you click the chart. Can you see the chart over here?
Yes.
Can? All of y'all? Okay. You click the chart. You take pie chart. Okay? Then you press continue. Now after that, alright, you look at this. I guess everything is fine. You just press OK. So when you press the word OK, you will get this three, you'll get this. 1, 2. So how you check is 74 over here. You copy and paste this and put it inside your assignment, and these two. Now this one you need to put in the percentage. Up to you how you want to do it. You want to copy paste and put the percentage inside also, up to you, or you want to put it Excel also, is up to you. Yeah.
But earlier when you were selecting the charts, there was an option.
Yeah, it doesn't work.
Can we lift it from Google Forms? Because it already
Yes,
has.
can. You want to lift it from the Google form also can. Up to you. Alright, so then you need to put in this two, and then you need to explain. Can? Alright, by the way, for reliability test, I forgot. Do you just copy and paste it in your assignment?
No, you gotta make a table.
Yes, you need to make a table. Understand? You need to make a table. So you see if you have 5 independent variables. So in your case, it's all 3 variables, right? So you need to put all 3 into a box table like. Okay, table like, and then you need to interpret. Same thing goes for the pilot study. Understand?
Yes.
Can. Okay. Now, once you have done the descriptive analysis, you have done the reliability analysis. Okay, so reliability analysis done already, you put the table. Now, the next one that you need to do is the normality test. Okay, so how do you go about the normality test? Okay, so we look at it. Okay, now we look at the normality test. So this is the one yesterday that you guys did. Alright? All of y'all can follow? Can? Alright, so far can follow, huh? Okay, so before you do the normality test, you must actually total up the items into one. Okay, you need to group them. Okay, so when you want to group them, you can put any name you want. Okay, so the common one is they'll write AVE underscore the variable, or most usually people use total underscore the variable's name. Okay, so in order to do that, okay, you go back to this, you need to transform. Okay, I'm going very slow because we still have time. Don't worry, that's why I'm doing the summary now. I wouldn't have done this. Okay, transform. Okay, then what do you do?
Compute variable.
Very good. Compute variable. You get this box, right? Okay, so when you get this box, okay, you look at the first one, POU. So you put that total, okay, underscore PEOU. Sorry. OU. Alright? So numeric expression, just open, close. Okay, and then you take here, put it over here, plus POU2 plus POU3, okay, plus POU4 plus POU5 plus POU6. Okay, so then I need to divide by 7, correct?
6.
6, very good. Okay, just want to test you all, if you all are really listening or not. Okay, so you divide by 6. How you know it's 6?
Because there's 6 variables. The question
Yeah,
is
there are
questions.
6 items here, right? Yes or not? So you put 6. Okay, guys?
Yes.
Can? And then you press OK. So you need to do for all the variables. So you will know in your data, you will see this thing over here. Total PEOU. Understand? Can? Can, huh? Okay. So now I'll close this one because I'll use the other data. No. No. Okay. Let's see. Okay. So end of the day, you will get all these things, right? Yeah? So normality has been, now you have done the transformation. So now what you need to do is, okay, you want to check whether your data is normal or not. So the rule of thumb is the p-value has to be more than 0.05. Clear?
Yes.
I'm going very slow. If you think it's still too fast, I'll talk slower. Okay, right? So the p-value has to be more than 0.05. Clear? Alright. Then after that, you need to analyze. Okay, so go to analyze. Okay, descriptive statistics. Now you need to put explore. Okay? Can? All of y'all? Clear? Okay. Explore. Okay. So when you explore, you get this table over here. So you see the word dependent list, right? Okay, so under dependent list, you go to the lowest one, you see which is the dependent list, is the total CI. So you move the total CI over here. Okay? Can? Right. Then the next one, if you look over here, you have plots. Click on the plots. So when you click on the plots, this has been automatically selected for you. You just need to select normality plots with tests. Okay? All of y'all? Can I? Okay. Then you press continue. Okay, then after that, you look at the options. So for normality test, all you need to do is look into plots and options, exclude cases pairwise, continue. Okay? Then you press OK. You will get this 3 table: case processing summary, descriptive test, and also test of normality. Now, if you do not select the earlier one under the plots, if you don't select normality test with plots, you will not get this table. Okay? Alright, so now what is the rule of, okay, so you realize there's something called Kolmogorov-Simrov, there's something called Shapiro-Wilk, right? There's something called statistics, there's something called standard error, right? Understand? Okay, so now you need to see whether your data is normal or not, right or not? So how to know if your data is normal? The p-value has to be
over 5, 0.05.
yes, over 0.05. Then the normality is being assumed. Okay? Alright. So now if it's not normal, then you have to do a Z-score. Okay?
Yes.
Alright. So if you want to know whether it's normal or not, you need to look at the test of normality. So since you have 74 and you look at the significant level is 0.067, which is more than 0.05, it's very easy for me. It shows it is significant. So I will use the rule to say that above 50 or 100, Kolmogorov-Simrov is acceptable. Because mine is 74, what? Above 50, right? Yes or no?
Yes.
So therefore, I look at my convenient and I say above 50 is Kolmogorov-Simrov, and I put a citation over there and I say it is. So I look at it. I look at this fella and I said it is significant. So therefore, since its p-value is more than 0.05, the normality is assumed. Understand or not?
And then we put a citation for this one?
Yes. Okay, you have to put that for the test of normality. Kolmogorov-Simrov is being used, okay, as the respondent size is 74. Understand? Okay, clear? But now, say for example, if this is 34, then we have no choice but to use this one. Okay, Shapiro-Wilk. Understand or not? So say for example, if you get 0.022, which is less than 0.05, you need to do a Z-score. Understand or not? So I'm just assuming if this, you guys use Shapiro-Wilk. So what is the rule for Shapiro-Wilk? Shapiro-Wilk is kurtosis over standard error, right? So where do you find this kurtosis over standard error? You look at the box above. Kurtosis, standard error. Understand? So the formula is statistics over standard error. So negative 0.307 divide by 0.552. So you get negative 0.5 something, example. So if it falls within the range of these three, it is acceptable. It means that the non-normality violation is not too serious. Why? Because it fell into the range of or greater than this thing, alright? This range over here. Understand?
Yes.
So therefore, the Z-score in this study is 0.2 blah 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 blah. But if your study is normal, do you need to do a Z-score? No need.
How do we calculate the Z-score?
The Z-score here. Formula is statistics over.
Oh, the one you just showed, the
Yes,
kurtosis one. Okay.
standard error. It's okay to ask me questions now instead of asking me questions late. When I'm not around. Okay, asking your friends and then you get more confused. Are y'all okay so far? So normality is okay? Anyone? You don't understand? Raise your hand. Don't be shy. Okay? Yes, yeah.
So if it's significant, you don't have to use the Curtis standard error.
No need.
So
If it's significant, which is p-value is here is more than 0.05, you just write what you got it, okay, like 0.6 something or whatever, and then say that the normality is being assumed. That's all. No need to do Z-score.
you have to do it within the range and all that.
No need. All that no need. Because I've already written here very good. Check if it's normal. If no,
I have a question about the range
do
thing.
Z-score. Yeah.
So those values, right, are they all negatives or?
Negative to positive.
So all of them are negative to positive?
Yes.
Okay, because the placement of those dashes were like confusing me a bit. Yeah,
okay,
yeah.
okay. Alright, if you guys want for this journal, I'll upload the journal for this. Okay, so you can even use the citation for that. Alright, so just remind me in case if I don't upload for so you can use that. Okay? If you want to find your own also, no problem. There's a lot of journals that says this. Okay? Alright, any more questions? Any more questions? No? Right. Okay, now the next one is what you call as linearity test. Okay, so linearity test, to be very honest with you, for FYP, I do not ask my students to do because you can see the linearity test in your Pearson correlation. But since you all are starting, you're learning the basic, I have no choice to teach you this. Okay, so for this assignment, you have to do. But when you go to FYP and your supervisor say, nah, no need to do linearity test, then don't do. Okay? Alright? But if he or she doesn't say anything, then just go ahead, do it. Okay? Because you never know. Alright? So, linearity test is basically you are explaining the R power of 2 over here. Okay? You're explaining. So, basically, you want to know the relationship between the two variables must be linear. You want to know how much the IV explains the dV. Okay, right? So in order to do this, you need to look at the y-axis. So y-axis is the dependent variable. Okay? The x-axis is the independent variable. You have to remember this. If you don't remember, it's okay. Just print this paper, keep it at the side as you write. Okay? Alright? So you just need to remember on this. Y-axis is dependent variable. X-axis is independent variable. So in order to do this, okay, you go back to this. Go to graphs. Okay? Go to legacy, scatter dot, Then simple scatter dot. Are y'all following? Kenna? Boys, y'all okay? Okay, Kenna, go. Towards the end, Kenna, no problem, all good, huh? Okay, simple scatter dot, define. Okay, then you have this. Y-axis is IV, right?
I forgot.
No. Y-axis is what? DV. I just told you, right? I'm just checking only. Okay? So y-axis is DV. So you take the DV over here, move it here. Okay? So X is always IV. Okay? Alright, so you take the total POU, you put it over here. Alright, then after that, I think, okay, just press OK. So when you press is OK, you look at the last one. Okay, you get this. So on this particular graph, you double click. You get a new box, right? So under this new box, okay, go to add fit line. See, you can see these three graph line. Okay, just go near one. You can see add to fit line. If you go to the next one, there's nothing. Third one is add interpolation line. So just go to add fit line at total. So just click here. So when you click here, can all of y'all? Then you just need to close. So you get the R linear over here is 0.351. So which means that, okay, so what are you trying to say here? Which means that it suggests that 0.351 of the dV can be explained by the IV, correct? Wrong. What does it mean?
0.35% off.
So 0.351, we have to change it to percentage.
Yeah.
Okay, he got an idea, but still wrong. Okay, 0.351, you need to change it to percentage, which is how many percent?
35.1.
35.1%. Understand? See, all of y'all forgot this. Okay? Alright, so the R power of 2, okay, it means that 35.1%, it suggests that 35.1% of the dV can be explained by the IV. Okay? Can, no problem. Now, this is a negative linear relationship, right?
Positive.
Oh, yeah. Because going this way.
I'm asking you, is this a negative linear relationship, right?
Wrong.
Positive.
Wrong. It's positive. How you know it's positive?
Like this?
Yes, it's going up, right? Yes or not? But if you are doing employee turnover or job insecurity, these kind of negative words, then it will go down. Understand?
Wow.
Can I? Okay. So is there a difference? If you get a negative, is this wrong? No. So positive linear relationship means that every unit increased by the IV, which is the total PU, the dV decreases at the same time, right?
Increase.
Very good. The dV doesn't decrease, my dear. I just want to check whether you all realize or not. The dV increases, right or not? See, when you go like that, if the IV increases, the dV also increases, isn't it? Yes or not? It makes sense, right? But I said decrease, that's not all of you keep quiet. Okay? So here it means that every unit increased by the IV, the dV is likely to increase at the same time. Understand? Can. So you need to do the same thing for all the IVs. So in your case, you have 2 IV, 1 dV. You need to do twice. Okay? This was yesterday's work and last week's work. All of y'all clear?
Yes.
Clear? Okay, so now we will look into the next new step. Okay, you have Pearson correlation